3.0, and it is a lesson on special angles. Now, special angles are the angles 30 degrees, 45 degrees, and 60 degrees. And we call them special because we're able to work out exact value ratios for all those three angles in any of the four quadrants. Now, the good news is they're easy and they make sense when you see them. The bad news is you have to have them memorized. So it all starts with a triangle like this, an equilateral triangle, which has got sides of 2 units. And if you have an equilateral triangle, it means that the angles within the triangle have to be the same. And they all three have to be 60 degrees. And then I'm going to take this triangle, which is not a right triangle, and I'm going to bisect one of the angles. In fact, I'm going to bisect the top one and turn it into this. And then I'm just going to look at one half of this because I want a right triangle. And this is what we're going to get. The right half would have a hypotenuse of 2 units. It would have the bottom side of 1 unit because we cut that 2 in half. It would have an angle of 30 degrees at the top, which is the bisected 60-degree angle. And then it has the 60 degrees on the bottom right. And in order to work out the trig ratios, we do need the third side. So we use Pythagoras' theorem to find that third side. And that's a squared plus b squared is equal to c squared. I'm not using the XYR version because we're not on a coordinate grid. So this is just regular sort of triangle work. So a squared is equal to c squared minus b squared because I am going after a. So 2 squared minus 1 squared is 3. So a squared is equal to 3. And you take the square root and you'll get square root 3. I'm only taking the positive square root because, again, I'm just treating this like as a regular triangle, not on a coordinate grid where I would consider plus or minus. Also, I do not decimalize it. I keep it as positive root 3. That's what I want for this one. Because it's got to be an exact value. It's got to be an irrational number in its simplest form. So if we look at the triangle now, this is what we get. And the rest of it is just working out the three primary ratios for this. So I'll move this off to the side, and we can now get the exact value. So we're not using a calculator. We're not going like sine 30 on our calculator or sine 60. We're just observing this triangle and taking out the ratios. We've got to be careful because they have to be known. You've got to get these ones, and your calculator won't give you all the answers because your calculators do not do irrational numbers generally. So they have to be memorized. And one way to do so is to draw this triangle out, say on an exam, and refer to it. That's one of the methods we use. But more on that later. First off, let's take the 30-degree angles. The sine of 30, which is opposite over hypotenuse, is 1 over 2, 1/2. Now your calculator would verify that. It will. That's one that you can solve on your calculator. However, the cosine of 30 you cannot get as an exact value on your calculator. It's equal to square root 3 over 2, adjacent over hypotenuse. On your calculator, you'd get 0.8660, which is a decimal approximation. So you must be aware that in order for it to be exact value, it's the square root 3 over 2. And that's what we'll be looking for. The tan of 30 is opposite over adjacent, so that's 1 over square root 3. You could rationalize that and write that as root 3 over 3. I'm not going to for this one. And there also will be more on that later on. If you now turn your attention to the 60-degree angle, you'll see that the sine of 60 is square root 3 over 2. The cosine of 60 is 1/2. And soon, if not now, you'll note these patterns that because it's the same triangle, your sine of 30, for example, is equal to the cosine of 60. Cosine of 30 is equal to sine of 60. So it's the same ratios for sine and cos. You just switch them off. And it's just a matter of keeping them straight. And then the tan of 60 is square root 3 over 1, or just plain square root 3. Now that takes care of it in degrees. However, we mostly work in radian measure. So if you went back to the triangle and I converted those degree measurements into rads, 30 degrees is pi over 6. Now you could convert that by the conversion formulas, but I hope by now that you're fairly comfortable with that. 30 degrees is the same as pi over 6, just as 60 degrees is pi over 3. So we can work out each of those ratios now in rads. So the sine of pi over 6 is equal to 1/2. The cosine of pi over 6 is equal to square root 3 over 2. The tan of pi over 6 is equal to 1 over root 3. So nothing's different, it's just that I'm using rads instead of degrees. If you keep on going into the pi over 3 or 60 degree angles, sine of pi over 3 is root 3 over 2. The cosine of pi over 3 is 1 over 2. The tan of pi over 3 is square root 3. Now I haven't looked at any reciprocal functions yet, although I will in the next lesson, but there's no big deal. If you need to get a reciprocal ratio, you simply flip over the primary one. So you don't have to make a special effort to memorize them. So there's 30 and there's 60. If you take a look at 45 degrees, we begin with an isosceles triangle with two equal sides of one unit. The idea with these little triangles is that you're trying to break it down to the smallest units possible so that you can, apply it to bigger ones. And that's why, if possible, you have the sides equal to 1. It wasn't possible with the 30 and the 60 because we had to start with 2 so that when we cut it in half, we produce the one we want. But here, two sides are 1, and the angles must be 45 degrees if it's going to be isosceles. And the third side would again be found with Pythagoras' theorem, a squared plus b squared is equal to c squared. So 1 squared plus 1 squared is equal to c squared. 2 is equal to c squared. So c is equal to the square root of 2. So we put this back on the triangle, and we get this. So the rest of it is just listing these ratios. The sine of 45, you can pick whichever 45 degree angle you want, and opposite over hypotenuse is 1 over root 2. And in this case, I will rationalize that denominator, although it isn't necessary to do so. However, many textbooks and workbooks do rationalize. So sine of 45, if you multiply top and bottom by square root 2 over square root 2, you'd get this. In my mind, both are the same. I don't care if you write it one version or the other. The reason is simply if you're dealing with a reciprocal function, the radical goes back to the bottom anyways. So there's really no advantage to rationalizing the numerator except or denominator except when checking your answers. The good thing about 45 degrees is you get the same cosine ratio. Cosine of 45 is equal to sine of 45, 1 over root 2. Better still is the fact that the tan of 45 degrees is equal to 1. That one your calculator would handle. Let's take a look at these in radian measure. 45 degrees is equivalent to pi over 4 rads. So the sine of pi over 4 is 1 over root 2, or as I've got it written, root 2 over 2. The cosine of pi over 4 is also equal to root 2 over 2. And the tan of pi over 4 is equal to 1. So that's what you need to know. They need to be memorized. The next lesson we'll be solving these ones, evaluating them. But this is another important lesson. Even though you'll only get a few questions on your exam that are specifically exact values of these, you use them over and over again. And with trigonometry, very often people get bogged down in the little things. It's not the big things, it's the little things. And it's practice with these smaller components of the course that make you good at trigonometry. Thank you for your time.